Welcome to The Explainer. Today, we're basically becoming cosmic detectives. We're going to investigate one of the biggest, most mind-bending mysteries in all of astrophysics, the case of the cosmic bullets.
All right, to get our heads around just how wild this all is, let's start with a question. Think about it for a second. What's the most powerful single particle, not a meteor, not a rock, a single tiny particle, that's ever hit our atmosphere?
The answer is absolutely staggering. It was a single subatomic particle carrying around 50 joules of kinetic energy. Now I know what you're thinking. 50 joules? That's not that much. But let's put that into perspective.
That's the same energy as a Major League Baseball fastball rocketing along at over 90 miles per hour. Now just imagine all of that power, all of that punch packed into one single, invisible, subatomic particle. It's just incredible.
So, what do we call these little powerhouses? They're known as ultra-high-energy cosmic rays, or, UHECRs for short. These are literally cosmic bullets, shot from somewhere out there in deep space, and they carry energies that just blow away anything we could ever hope to create here on Earth, even in our biggest particle accelerators. And for 60 years, we've had no idea where they come from.
So, you've got a 60-year-old cosmic cold case. Where do you even begin? Well, like any good detective, you start by gathering the evidence. You look at the clues these particles leave behind when they hit. And you know what? After decades of work with some seriously sophisticated detectors, we've actually got 3 really solid clues that help us narrow down the list of suspects.
Okay, clue number 1. The fingerprints these things leave behind when they smash into our atmosphere tell us a lot about what they are. And the evidence points to them being heavy nuclei, like the core of an iron atom, not just simple lightweight protons. So that tells us something important. Their birthplace has to be somewhere that can cook up heavy elements.
Clue number 2 is super interesting. They're not just coming from everywhere at random. Nope, there's a pattern, a hot spot in the sky, which suggests they're pointing back to their source. But, and this is a huge but, our galaxy's magnetic field acts like a giant funhouse mirror, bending their paths all over the place. So the trail is there, but it's totally scrambled.
And now for our third, and maybe most powerful, clue. By counting up how many of these cosmic bullets hit us over the years, scientists have actually calculated a total energy budget for them across the entire universe. Think of it like a power bill for the cosmos. It tells us the absolute minimum amount of energy that whatever's making them has to be cranking out year after year. So why is that number so important? Well, it's a hard limit. It acts like a filter. Any potential source, any cosmic suspect that can't contribute to that massive power bill gets crossed right off the list. It immediately rules out a whole bunch of possibilities.
Okay, so we've got our clues. We know they're heavy, we know they're coming from a general direction, and we know how much power it takes to make them. So the next question for our cosmic detective case is, how? What's the modus operandi? How could the universe possibly accelerate a particle to these insane speeds?
Well, physics gives us 2 main ways it could happen. The first is basically a cosmic pinball machine. A particle gets bounced back and forth across a giant shock wave, gaining a little more energy, a little more speed with every single bounce. The second involves these insane electric fields created by rapidly spinning, supermagnetized objects that can just grab a particle and fling it across the universe.
So we have the clues, we have the methods. I think it's finally time to assemble our lineup of the prime suspects.
And let me tell you, the things that fit this profile, they have to be some of the most violent, most energetic phenomena that the universe can even produce. These are places that don't just have the raw power, but also use the right physics to launch these cosmic bullets.
And this brings us to our 2 prime suspects. Suspect number 1, relativistic jets. These are gigantic fire hoses of matter getting shot out at nearly the speed of light from the supermassive black holes that live in the hearts of galaxies. Suspect number 2, intergalactic accretion shocks. These are just colossal shockwaves, bigger than entire galaxies, that form when whole clusters of galaxies smash into each other. Yeah, both are powerful enough to fit the bill.
So we have our suspects in the lineup. But how do we get that final piece of evidence to point the finger and say, aha, it was you? How do we finally crack this case?
Well, the big break probably isn't going to come from just finding another cosmic bullet. The real breakthrough is going to come from a whole new way of investigating. It's about looking for accomplices to the crime, other signals that get sent out from the very same violent event.
This revolutionary new technique is called multi-messenger astronomy, and it is the ultimate forensic toolkit. It means combining the cosmic ray evidence with other messengers, like light or ghostly particles called neutrinos, or even ripples in space-time itself, gravitational waves. You put it all together, and it's like seeing the crime scene from every possible angle, all at the same time.
Just imagine seeing one of these ultra-high-energy cosmic rays arrive from the exact same spot in the sky where we also detect a flash of light and the echo of gravitational waves. That would be the smoking gun. We could finally pinpoint the source. So the question is, after 60 long years, will this team of cosmic messengers finally unmask the universe's greatest culprits? The evidence is building, and honestly, the answer could be just around the corner.